In this video, we shall look at a few problems associated with force and motion. Elevator problem. An elevator and its load have a total mass of 900 kg. The elevator is originally moving downward at a speed of 9 meters per second, as indicated by this arrow. It is then brought to rest with a constant acceleration in a distance of 30 meters. Calculate the tension in that supporting cable. So after the elevator has traveled, say, a distance of 30 meters, it comes to a complete rest. That means the acceleration is heading upward. So let's figure out that acceleration. We know it is a constant acceleration, so kinematics apply. The initial speed is 9 meters per second. The final speed is 0 meters per second, meaning it comes to a complete rest. So U is 9 meters per second, V is 0 meters per second, and it has traveled a distance, let's say delta x, 30 meters. So what is A? Using one of the kinematics equation, namely V squared minus U squared equals 2 times acceleration times the distance traveled, we can figure out the acceleration because we know all the other unknowns. So let's substitute the numbers. V is 0, so 0 squared. U is 9, so 9 squared equals 2 times acceleration times delta x. Delta x is 30 meters, that one. And A turns out to be minus 1.35 meter per second squared. Now it is minus because the direction of acceleration opposes the direction of motion. So now we know the acceleration is in an upward direction with a magnitude of 1.35 meter per second squared. Let's proceed to determine the tension in the supporting cable. Let's first sketch the free body diagram for that elevator system. Now we know the weight is 900 times gravity because the mass is 900 kg. The tension is going upward, so that's tension right there. The acceleration is in an upward direction. So using Newton's second law, the net force is tension minus 900 g. So this, subtract that, is the net force. And that net force must be the same as MA. M is 900, A is 1.35. And the tension can be determined. And the answer is 10,044 newtons. And that solves the problem. Let's look at the second problem, the train problem. A train, an engine with 4 cars. So this is the engine, and these are the cars. There are 4 of them. The system is accelerating at 0.9 meters per second squared. If each car has a mass of 40,000 kg, find the force of the engine on the first car. So the amount of force that this exerts on that. Let's look at the free body diagram of object or car 1. So the force exerted by the engine on car 1 can be written as Fe1, and at the same time there is force exerted by 2 on 1. So let's call it F21. That happens there. Car 1 goes forward with acceleration A given by 0.9 meters per second squared. So you see you can write the force by engine on car 1 minus the force by car 2 on 1 equals the mass of car 1, for now let's take that to be m, times the acceleration of car 1, which is just a. Let's call this equation equation 1. Now let's look at the car 2. So car 2, it's being pulled forward directly by car 1. So the force is the force exerted by 1 on 2. And it is being pulled behind by car number 3. So that is the force by 3 on 2. Applying Newton's second law on car 2, we get F12 minus F32 equals ma, because the mass of car 2 is also m, and that is equation 2. We note here that the force on 1 due to 2 that goes like that is the same as the force on 2 due to 1 that goes like that. So these two terms must be the same. If they are not the same, this link would break. Now let's look at car number 3, the free body diagram of car number 3. The force on 3 due to 2, we can write it as 2, 3 like that. It opposes the force on 3 by 4, which happens in that link, and the direction is backward. So let's write that as F4, 3. The mass is again m, and the acceleration is a. Again, applying Newton's second law for car 3, we get F23 minus F43 equals ma, and that is equation 3. Again, F23 and F32 are the same, because that happens in this link. F on 3 by 2 goes that way, and F on 2 by 3 goes that way. Now the final free body diagram, namely car number 4. The force that acts on it is due to car number 3. So the force on 4 due to 3 can be written like that. And since the acceleration of car 4 is a, we can simply write F34 equals m times a. So that is equation 4. And again, we stress the force on car 4 due to car 3, which goes like that, must be the same as the force on car 3 due to car 4, which is going like that, and they are the same. Now we can answer part A, the force of the engine on the first car. So let's look at equation 4. We know F34 is ma, so that is ma, so that means F23 is 2ma. So let's write that down. F23 is 2ma. Substituting F23 equals 2ma here, you get F12 to be 3ma. And finally, substituting F12 equals to 3ma there, you get that Fe1 equals to 4ma. So there we have it. The answer for part A, the force of the engine on the first car, namely Fe1 equals 4 times m is 40,000, times a, which is 0.9 meter per second squared, and that's going to be 144,000 newtons. Now let's look at part B. Force of the first car on the second car, that means this one, and that is 3 times ma. So that is 3 times m is 40,000. A is 0.9, and that's going to give you 108,000 newtons. Now for part C, the force of the second car on the third car, that is this one, F23. And F23 is 2 times ma. So 2 times mass, 40,000. Acceleration is 0.9, and that's going to give you 72,000 newtons. And finally, D, force of the fourth car on the third car, that we labeled as 4, 3, and that is quite simply ma, because as we pointed out, is the same as the force on the fourth car by the third car, so 3, 4, which acts that way. So m is 40,000, and A is 0.9, and that's going to give you 36,000 newtons, and that solves the problem. Problem 3. A window washer pushes the scrub brush up vertically, like that, on a window at constant speed by applying a force F that goes in that direction. The brush weighs 6 newtons. The coefficient of kinetic friction is 0.3. So that is the coefficient of kinetic friction between the brush and the surface of the glass. Find the magnitude of that force F and also the normal force exerted by the window on the brush. Let's look at the free body diagram of that brush. The motion is that way because it's being scrubbed vertically upward. So that means weight is downward. It's okay. Normal force and F. We know this happens at constant speed, so the acceleration is 0. So what that means is the vertical component of F must be balanced by the sum of that kinetic friction and weight. The vertical component of F is given by F cosine that angle. So what is this angle here? That angle theta is 90 minus 50 degrees. 50 degrees is that. That is the angle that scrub makes against the horizontal. So if this is 50 degrees, so that must be 40 degrees. So theta is 40 degrees. So the y component of that force F is F cosine 40 degrees, and that must be the same as the kinetic friction plus the weight. This kinetic friction equals the coefficient of kinetic friction times the normal force, that normal force. And from the diagram we see the normal force which is going this way must be balanced by the x component of that force F which is going that way. So that is the x component of that force F, and in terms of angle it is quite simply F cosine 50 degrees. You see the F is going that way. That angle there is 50 degrees, that angle. So the x component, F sub x, is F cosine 50. So let's substitute everything. F cosine 40 degrees equals Fk. Fk is mu k. Mu k is 0.3 times the normal force. Normal force is given by that expression. F cosine 50 degrees plus weight. The weight is 6 newtons. It's given right there. And you see the only unknown is F, and that can be solved. And solving for F, you get F to be 10.47 newtons. So that is the answer for part A, namely magnitude of that force F. Knowing that, we can determine the normal force, and that is given by that expression. So the normal force is F, which we have determined, 10.47 times cosine 50 degrees, which will give you 6.73 newtons. And that solves the problem. Thank you for watching.